Hello, how are you doing? This is Mike, and in this video we're going to talk about how to solve absolute value inequalities. And this is going to differ slightly from the last video where we solved equalities or equations. In this circumstance, we're going to talk about inequalities. So just as a quick reminder, if we solve inequalities, our solution will always be an interval, So at least one interval. Sometimes it might be a series of multiple intervals, but it will never be just a finite value or finite values. It will never just be one or two or three solutions. It will always be on an interval. So remember that parentheses and brackets have a meaning here. So remember, if you see a parentheses versus a bracket sign, you should be thinking less than or greater than. If you see brackets, you might be thinking less than or equal to or greater than or equal to. So be very, very careful with this circumstance because they have different meanings here. So let's go ahead and discuss our first protocol. So if we have the absolute value of x set less than a value of k, and this is going to be our first, formula that we can recognize. And remember, this holds true for less than or equal as well. So if we see less than, that also holds true for less than or equal to. So what does this imply? This implies that negative k is less than x, which is less than a value of positive k. So this actually is going to be considered a compound inequality. So this is a compound inequality. A compound inequality. So let's go ahead and try an example. So let us say we have the absolute value of x less than or equal to negative or positive 3. Now, just as a little reminder too, this value of k will be greater than or equal to 0 for right now. So this value of k will be greater than or equal to 0 right now. So let us go ahead and examine our absolute value of x being less than or equal to a value of positive 3. This implies that negative 3 is less than or equal to a value of x, which is less than or equal to positive 3. But remember, we must write our solution in terms of an interval or set notation. So if we want to write this as set notation is relatively simple. We're just going to write the set of x such that the argument that we just determined, which was negative 3 is less than or equal to x, which is less than or equal to positive 3. If you want to write it in interval notation, we're going to have to use, I always recommend graphing it and using a number line. So let's look at this portion first. Let's look at negative 3 is less than or equal to x. So here we're going to have 0 and then negative 3. If negative 3 is less than or equal to x, that implies that x is greater than or equal to negative 3. So I'm going to use a bracket intersecting at negative 3, and I'm going to draw an arrow to my right. And then I'm going to look at this second part. So I have x is less than or equal to 3. So x is less than or equal to 3, so I'm going to draw a 3, my critical point of 3. And this will get a bracket opening to the left, and then I'm going to get an arrow that draws to the left. And the solution will be wherever they overlap. So clearly, they overlap from negative 3 to positive 3, and this is inclusive. So this is actually interval notation. So depending on what professor or what instructor wants what, you could either want set notation, which is this notation, or interval notation, which is that notation. So there are two different ways to write this. I recommend practicing both just to make sure that you're familiar with how to use both notations. Let's go ahead and try another example. Let us try the absolute value of 2x plus 6 is less than positive, let us try positive 8. So what does this imply? This implies that negative 8 is less than 2x plus 6, and this is going to be less than positive 8. So we can go ahead and drop off those absolute value signs if we set it equal to that form. So now we're solving a compound inequality, so you can do this two different ways. You can split this up, so I'll do this way, number one. So I'll split this up as negative 8 is less than 2x plus 6, and 2x plus 6 must be less than positive 8. So you can do it this way. So let's go ahead and solve it this way and see what we get. So we can subtract 6 on both sides. Subtract 6 on both sides. And we get negative 14 is less than 2x. Divide both sides by 2. And we get negative 14 is less than x, which is the same thing as me saying x is greater than negative 14. We're going to subtract 6 on both sides, and we get 2x is less than 2. Divide both sides by 2, and we get x is less than 1. And notice here we're conjoining these two different intervals by the term and, so we have to determine where they overlap, because remember, and means overlap or coexist. So and overlap are the exact same thing. Looking at this on a number line, we're going to have a critical point of 0, a critical point of negative 14, and a critical point of positive 1. And again, this is not drawn to scale. I'm just emphasizing the critical points. Looking at the first inequality, we have x must be greater than negative 14, which means that we're going to have a parenthesis opening to my right. And then we have over here that x must be less than 1, which can be a parenthesis opening to my left. And since we use the term and, we have to determine where these solutions overlap, and they clearly overlap in this blue portion. So we can write this as an interval notation, negative 14 all the way to positive 1, included, non-inclusive. So we're not going to have a set of brackets, only a parentheses, because our inequality symbol was a less than. So now let's go talk about how to solve this using way 2 of solving the compound inequality. So the second way of solving the compound inequality is just to do whatever you do in the middle to both sides on the left and the right. So now if I go ahead and subtract 6 in the middle, I have to subtract 6 on my left and subtract 6 on my right. And I'll have negative 14 is less than 2x, and this will be less than positive 2. And now I'm going to divide 2 by in the middle, because I want to isolate my x, which means I divide 2 on the left and divide 2 on the right. So I will have negative 7 is less than x, and this is less than positive 1. So if I want to write this in set notation, and oh my goodness, look at that. So I'm glad I did this. I caught a mistake. So this actually is not going to be negative 14. This is going to be a value of negative 7, which changes this. So I made a little mistake here. So I'm glad I caught that. Negative 7, and that makes this to be negative 7 as well. So hopefully you see my little error. I said negative 14 divided by 2 is in fact, be careful here, I'm going to write a little star, is negative 7. So that changes my solution all the way around. Of course, I have issues doing simple division, go figure. So we're going to have negative 7 less than 1, negative 7 all the way to 1. So we can write this as set notation. Solving it this way leads it to be, leave the answer to be interpreted in set notation. We're going to have the set of x such that negative 7 is less than x, which is less than positive 1. And again, we can write this in interval notation the exact same way from negative 7 to 1. So either way you'd like to write that is okay with me. However, sometimes your instructors may be a little more particular on the presentation of your solution. So again, just as a reminder, this is set notation, this is set notation, and this is interval notation.